In lesson 2, we are going to discuss about solving rational equations involving direct, inverse, and joint variation. Direct variation. It is a variation where one variable is a constant multiple of another one, or y varies directly as x if there is a constant k such that y equal to kx, or y over x is equal to k. These are the two relations that we are going to use for solving these problems related to direct variation. A real world example. The number of dollars I make varies directly with how much I work. So that means the more hours I work, I will make more money. That is a direct variation. Example. Find y when x is equal to 10 if y varies directly as x and y is equal to 9 when x is equal to 6. So x and y are given. We can use the relation which is y is equal to kx, or 9 is equal to k multiplied by 6 is given here, or k is equal to 3 over 2. We can use the value of k back in here, so y is equal to kx, and we need to find y when x is equal to 10. We already know k is equal to 3 over 2 and x is 10. So the question is 2 goes in 10, 5 times 5 times 3, 15. So y is equal to 15 when x is equal to 10. Inverse variation. In this variation, when one of the variables increases, the other one decreases, or y varies inversely as x if there is a constant k such that y is equal to k over x, or xy equal to k. So these are the two relations that we are going to use to do the problems under inverse variation. Let's talk about a real-world example. This is relating the three components of distance, speed, and time, or distance, velocity, and time. So the time traveled is inversely related to the velocity or speed if the distance is constant. And we know this relation t is equal to d over s, where t is the time, d is the distance, and s is the speed or the velocity. Example. Find y when x is equal to 20 if y varies inversely as x, and given y is equal to y when x is equal to 16. So first let's write the relation. Y is equal to k over x, and we know y is equal to 5, and x is equal to 16, so we know k is equal to 5 times 16, 80. Use that value over here to find y when x is equal to 20. So y is equal to k over x, and y is equal to k is 80, and we know x is equal to 20. Y is equal to 4. So this is an example of an inverse variation. Joint variation. This is a type of variation where more than two variables are related directly, or y varies jointly as x and z if there is a constant k such that y is equal to k times xz, or y over xz is equal to k. So these are the two relations that you can use while doing the problems under joint variation. Here's a real-world example. We know the formula for the simple interest is I is equal to P times R times T, where P is the principal, R is the rate of interest, and T is the time period. or the interest earned on a savings account varies jointly with the amount of money invested P and the time T for a fixed interest rate R. Example: find y when x is equal to 4 and z equal to 9 if y varies jointly as x and z, and y is equal to 10 when x is equal to 2 and z equal to 3. Let's work out this problem. And we know the relation is y is equal to k times x times z, or y is equal to 10. We have to count k, x is 2 and z is 3. Okay, so we know 10 is equal to 6k, or k is equal to 10 over 6 or 5 over 3. K is equal to 5/3. Okay. Now we know y is equal to k times x times z, and y is equal to, we are trying to find y when x is equal to 4. We know already k is 5/3, x is 4, and z is 9. Let's do the math. 3 goes in 9 3 times. 3 times 4, 12. 12 times 5 is 60. So y is equal to 60. So that was an example of joint variation.